This shouldn't happen. Ice, in normal conditions, melts, that's the rule. You leave it outside, it gets warmer, and slowly turns into water. Simple. So how can something make ice get even colder? So cold that it can actually freeze things faster? Because that sounds completely backwards. You're adding something to ice, and instead of melting faster, it drops in temperature. Not a little, but drastically, enough to go below freezing. So what's really going on here? Because this isn't a trick, it's something real, something you can test at home. Right now, all you need is ice, and something most people already have. Salt, just regular salt, nothing special, no chemicals, no machines. And yet, when these two combine, something strange happens. So let's test it. Same ice, same environment. No changes, just a normal setup. Take 2 containers, fill both with ice. Leave one exactly as it is. That's your control. Now take the second one and add salt. Sprinkle it directly over the ice. At first, nothing dramatic happens, no big reaction, no instant change. And this is where most people think, this doesn't work. Because they expect something visible immediately. But this isn't about what you see first. It's about what starts happening quietly, right after the salt touches the ice. Because something important just changed. And it has nothing to do with melting speed. At least not in the way you think. Now wait, give it a moment, look closely. The salted ice starts to look different. It becomes wet faster, more slushy, less solid, which makes it seem like it's melting quicker. And that's where the confusion begins. Because yes, it is melting. But at the same time, the temperature is dropping. And that's the part most people completely miss. Because melting normally means warming up. But here, melting is actually causing cooling, which shouldn't make sense. So now the question becomes, how can ice melt and get colder at the same time? Because if that's true, then this isn't just melting anymore. This is something else, something that can go below zero, without a freezer. And if you've ever seen people make ice cream using just ice and salt, this is exactly how they do it. But why does salt change everything? What does it actually do to the ice? Because without understanding that, this just looks like a weird reaction. And most people stop right here, without realizing what's actually happening. So before we jump to conclusions, let's compare both sides again. The normal ice, still solid, melting slowly. Nothing unusual, exactly what you'd expect. But the salted ice, more liquid, more unstable, clearly changing faster. And yet, if you measure the temperature, you'd find something surprising. It's colder, not warmer. Colder than the regular ice. And that's where this stops being obvious and starts getting interesting. Because something deeper is happening here. Something that completely changes how freezing works. And once you understand it, you can use it. Control it. Even push temperatures lower than you thought possible. Without any machine. So what exactly is salt doing to the ice? And why does this simple combination break one of the most basic rules of temperature? So what is salt actually doing here? Because it's clearly not just melting ice, it's changing something deeper. Something most people never think about. Freezing point. Every liquid has a temperature where it freezes. For water, that point is simple, 0 degrees. That's the line. Above it liquid, below it solid. But here's what most people don't realize. That line is not fixed. It can change. And that's exactly what salt does. The moment salt touches ice, it starts dissolving, mixing with the thin layer of water on the surface. And when that happens, it lowers the freezing point. Meaning, water now needs to be colder than 0 to freeze, not 0 anymore. Lower. So now you have a problem, because the ice is sitting at around 0 degrees, but suddenly, that temperature is no longer cold enough to keep it frozen. So what happens? The ice starts melting. But this isn't normal melting, because to melt, ice needs energy, heat. It has to pull that energy from somewhere. And since there's no external heat source here, it pulls it from the surroundings, from the ice itself, from the mixture, from the air around it. And that's the key moment, because as it pulls that heat away, the temperature drops fast. So now you have two things happening at once. The ice is melting, but the system is getting colder. Colder than normal ice, colder than freezing. And that's how this breaks the rule. Because the rule was based on pure water. But this is no longer pure water. This is a saltwater system with a completely different freezing point. And the more salt you add, the lower that freezing point goes, which means the system keeps pulling more heat, dropping the temperature even further, until it reaches a new balance. And that balance can go far below zero. Cold enough to freeze things faster. Cold enough to make ice cream. Cold enough to feel like something is wrong. But it's not wrong. It's just physics. Working differently than you expect. Now go back to the two containers. Normal ice, staying close to zero, doing nothing special. But the salted one? Actively pulling heat, actively lowering temperature, and creating a colder environment. Even while melting, that's the paradox. And that's why this feels confusing. Because visually, it looks like it's getting weaker, more liquid, less solid. But thermally, it's getting stronger, colder, more powerful. And this is exactly where most people misunderstand it. They see melting and assume it's warming up. But here, melting is the reason it's cooling down. And once you understand that, this stops being a weird trick and becomes a tool, because now you can control temperature using almost nothing, just ice and salt. But there's still one important part missing, because if you try this the wrong way, you won't get the full effect. You'll see some change, but not the extreme drop. And that's why many people say, it didn't work. So what's the mistake, and how do you actually push this to its lowest temperature? So why do most people fail with this, even after understanding everything? They still don't get that extreme cold. And the reason is simple. They don't push the system far enough, because just adding a little salt isn't enough. You need the right balance. Enough salt to actually lower the freezing point significantly, and enough contact with the ice to keep the reaction going. But here's the first mistake. People sprinkle a small amount, then stop. That only creates a slight drop in temperature. Nothing impressive, so it feels like it doesn't work. But when you add enough salt and mix it properly with the ice, now the entire system changes. More melting happens. More heat gets pulled out, and the temperature drops much lower. Now here's the second mistake. No contact. If the salt sits in one place or doesn't spread evenly, only a small part of the ice reacts. The rest stays normal. So you don't get the full effect. That's why mixing matters. Breaking the ice slightly, letting salt reach more surface area. This increases the reaction and makes the cooling stronger. But the biggest mistake, people expect instant results. They add salt, wait a few seconds, and assume nothing happened. But this process builds over time, slowly. The temperature keeps dropping, as long as the system is active. Give it a few minutes, and the difference becomes obvious. Now here's where this becomes powerful. Because once you understand this, you can actually use it to cool things faster, to freeze liquids, even to make ice cream without a freezer, all from a simple combination. Now think about that. You didn't add cold, you removed heat, using something most people ignore. And this is exactly why this feels so counterintuitive. Because everything about it looks wrong. Ice melting, but getting colder. A simple kitchen ingredient, creating extreme temperatures. But once you understand the system, it makes perfect sense. And more importantly, you can control it. So next time you see ice, you won't just think about melting. You'll know there's a way to push it even colder. If this changed how you think about something as simple as ice, there are a lot more everyday things like this that behave completely differently than people expect. So if you want to see those, hit subscribe. And if you've ever tried this before, drop a comment and tell me what happened. Most people miss one small detail.